Welcome to the latest edition of the Mind-Gut Conversation podcast, a place to learn about new ideas from thought leaders in the area of optimal health, the science of mind-gut microbiome interactions, food, and the environment. Today, I have the great pleasure to speak to Nathan Price, co-author with Leroy Hood of the Age of Scientific Wellness book. Nathan is Chief Scientific Officer of the supplement company Thorne and was previously CEO of Onegevity, an AI health intelligence company that merged with Thorne prior to its IPO in 2021. In 2019, Nathan was named as one of the 10 emerging leaders in health and medicine by the National Academy of Medicine. And in 2021, he was appointed to the board on life sciences of the National Academies of Sciences, Engineering, and Medicine. He spent much of his career as professor and associate director of the Institute for Systems Biology and has received numerous awards, including a Healthy Longevity Catalyst Award from the National Academy of Medicine. Yeah, so it's a real pleasure to talk to you, Nathan. Been inspired by your book, The Age of Scientific Wellness. I would highly recommend to our listeners to read this book. It's a real eye-opener. And I was going to start this this conversation with a question. In this book, you lay out a blueprint for a major paradigm shift in our understanding of health and wellness, health and disease, and in the way humans will prevent, treat, and cure the major diseases that are currently the exclusive domain of our disease care system. And before we get into some of the exciting details of the book, could you explain briefly how you arrived at this point in your illustrious career?
Well, thank you, Emma. It's wonderful to be with you. I started my career, my independent career at the University of Illinois in Urbana-Champaign. And I was probably going down a relatively conventional track to start with. I had been an American Cancer Society funded postdoctoral fellow. I was doing lots of work in disease research. But as I was moving forward more and more, I just came to believe that we were intervening in disease much too late, and that we had organized so much of the scientific enterprise, disease by disease, and that in systems biology, which is the discipline that I come out of, as does Lee Hood, my co-author on the book, there's such a focus on getting these case control studies late, where you're getting at, and by that point in time, hundreds of things have changed, thousands, and it gets to be very, very complicated. And so became really fascinated about trying to change that paradigm. So I was at the University of Illinois for about 4 years, and then was recruited back to the Institute for Systems Biology, where I teamed up with Lee Hood again. And the two of us launched, we're very in line with how we were thinking on this kind of an approach. And so we launched something called the Pioneer 100 project, which I'm sure which we can get into in a lot of detail. But basically, it was a project to try to make more practical this notion that we really had to revamp the way that we were looking at science and medicine and try to study people while they're still well. Try to understand health before you try to understand disease. And this led to this whole kind of paradigm shift that we'll talk around, which we call scientific wellness. But so in terms of my career then, that's when I really started going in different directions, devoted most of the last 10 years to this area of scientific wellness. We're still doing disease work of various kinds, but this became kind of the major paradigm. And then about 3 years ago, I went through a career transition where I went on leave from the Institute for Systems Biology, moved into a company, first as CEO of a company called Onegevity, a health AI company, which was then merged with Thorne, which is a high-quality natural product maker here in the United States, to form Thorne Health Tech, which was aimed at being a scientific wellness or healthy aging company. We took that through an IPO a few years ago. And then recently we were acquired by L Catterton, take it private, but that basically is a large-scale effort to try to make a lot of the solutions that we talk about in scientific wellness available to lots of people. And that company, Thorne, we work with about 7 million customers and about 50,000 physicians today.
And what was I'm sort of curious. So a lot of people may not have heard about this company, Thorne. What were the products based on your new philosophy and your conceptualization of medicine and health, really?
Yeah, so the products are the way that Thorne is organized, and it's still going through, I would say, a lot of the changes. But this would involve things like a microbiome test. So you can measure the thousands of different species in your gut, connect that to health recommendations. Blood-based tests. We developed a blood-based biological age test, for example, based around clinical labs, because those are today the most validated and the most predictive of health outcomes. So we did that. Large-scale panels. This was also part of an acquisition we made of a company called Wellness FX, which gave people an ability to look longitudinally at their measures. So we brought that in. And then we've coupled that with a large catalog of about 300. These are mostly, nutritional supplements and things of this nature. So it might be nicotinamide riboside as an NAD precursor, quercetin, which has anti-senolytic activities, sulforaphane out of broccoli, which impacts health span across a wide range of animal models as well as in some human studies. Anyway, a whole panoply of that, but the idea is really not around any one solution, but rather to try to give people an ability to make a lot of measurements out of their body, personalize, and then through lifestyle recommendations as well as targeted interventions. And we have focused, or I have focused mostly lately on the natural product space. That's been an outcome, I think, of aiming so much towards prevention, because I think there are some drugs that are very intriguing in this space, rapamycin, metformin, depending on how you categorize them. I think that the GLP-1s are very interesting in this space, pretty revolutionary. So there are drugs that I think are a part of this, but natural products is a very, I don't want to say natural place to go, but a kind of obvious place to go when you're talking about wanting to do interventions early on that have an incredible safety profile so that you're not introducing harm, because most drugs are aimed at late stage disease. And so they are like heavier hammers. You're going to hit a target much harder than you will with any existing natural products in almost every case. But they typically come with a big side effect profile. That trade-off makes sense in late stage disease. It doesn't really make sense generally if you're talking about people who are asymptomatic. So you have to think a little bit differently when you're aiming at prevention.
So before we get deeper into this exciting area, you mentioned a couple of terms which I think are really key to this conversation, and maybe not everybody who's listening is familiar with them. So one is obviously systems biology, and maybe you can just say, like, in one sentence what's understood under these terms. Another one is disease span versus health span, and a third one, chronological age versus biological aging. Do you want to just say a sentence to each of those?
Yeah, I'd be happy to. So systems biology is basically just an approach that is complementary to molecular or reductionist biology. So biology for a long time was, let's take the body and figure out what are all the pieces. This led to things like the discovery of the structure of DNA and so forth. Systems biology is the flip side of that. It says, given all these pieces, how do they operate together to lead to the phenotypes that manifest as, all the behaviors and capabilities that we have as organisms, and all the way up to ecosystems and so forth. So that's systems biology. In terms of chronologic age versus biological age. So chronologic age is, of course, just the number of times that the planet's gone around the sun while we've been alive. We're all very familiar with what our birthdays are and so forth. Biological age is the view that aging should be mostly understood as a process of damage in the body. And so the rate at which you are aging under that auspice is different person to person. So it matters, your genetics matter to that. If you're smoking or drinking heavily or being too sedentary or eating too many sweets, or you're a super exerciser or whatever it is, that has an effect on the rate of damage that's accumulating in your body. And that's what's referred to as biological age. So your biological age does not need to be your chronologic age. And so your biological age can be a metric, one of the things that we call a metric for wellness, meaning that it's something that can be improved. So if your biological age is younger than your chronologic age, that would be a sign of good health. And if your biological age is older than your chronologic age, that would be a sign of ill health relative to your age. And so health span is what a lot of us in this field are really talking a lot about these days. It's partly to stay away from talking so explicitly about longevity. Longevity is itself very important, but it's a little bit different. Longevity is how far can you push the date of your death into the future. But health span can relate to that, but health span in general is the space of your life that you live basically healthy. A good way to put this, it was interesting, I was actually on my way up to give a lecture at RPI a few months ago, and I was driving and I was listening to a book. Not a recent book. This is a book from 2,000 years ago, written by Seneca the Younger, one of the Stoics. You know, his letters to his it's called the Moral Epistles. I think I was on somewhere in the 70s. I don't know, 74 or 5, one of these. But I was going through it, and it turned out that the next letter that popped up as I was driving in my car was on longevity. And he had a really good way to put this, which he said, as he's given advice to his young counterpart at the time. He said, the key is that you want to extend your life and not your death. And I thought that was just the perfect way to put it, because that's what health span is. Health span is trying to extend the period that you're healthy and happy and moving, and not that end period. I'll share one other thing, which really motivates me in this way. One of my grandfathers, my dad's dad, I remember visiting him in the hospital before he died. And, we saw him a few times during the last, let's say, 3 years of his life. And he had mostly lost the power of speech. So I only heard him in those 3 years say 4 words the entire time, which he struggled to get out, which were, I want to die. And that was it. And so you can imagine, and Atul Gawande, of course, wrote this book, Being Mortal, that gets at this, which is there's that. And that's why when so many people, when you say, do you want to live a long time? Do you want to extend your longevity? They say, no, I don't want that, because they're thinking about that extension of death. So that's why we talk about health span. We want to extend life. We don't want to extend the period of your death.
Yeah, this is, I guess, a very helpful introduction to this conversation. I was going to ask you another question. So you have addressed several times the seeming contradiction between the dramatic success of 20th century model of healthcare and the realization that it is ineffective meeting the challenges of the 21st century. One of the major challenges is what has been called the chronic non-contagious disease epidemic that has unfolded pretty much since the end of World War II, over the last 100 years. I mean, there's a beautiful chapter in your book on this, the remarkable success. A lot of people now in this sort of alternative healthcare industry are bad-mouthing medicine, but I mean, obviously, medicine has done a phenomenal good thing for humans. It's just outdated. The model is just outdated. Do you want to expand on that a little bit?
Yeah, I'm so glad you brought that up. There does tend to be this dichotomy between, some people in the wellness world, right, and then the disease care form. There's this anti-bend towards pharma and traditional healthcare, and and I think it's really important to not overplay that, not to throw out the baby with the bathwater, so to speak. So I am in favor of pretty revolutionary change in terms of our focus, which I'll talk about in a moment. But I do want to acknowledge so much good that has come out of the current paradigm. So if you go back to the early 1900s, that is a world in which every third coffin held the body of a child who had died from an infectious disease. We ended that. Modern medicine, as we call it, ended that. in the developed world, not in the developing world. There are still places that is. It's interesting. I had a chance one time to meet Bill Gates some years ago, and it was interesting because someone had brought up, that these kind of things were, were largely solved. And it was, and he like pounded his fist on the ground. He's like, "You tell me one person who's really tried hard on typhoid," and it really made me respect him even more. I mean, it was really kind of been a very impassioned, of course, with his foundation. He's maybe done more than any living person for, trying to make a difference in that now. So, kudos and respect to him for that. So there is that, but we had this huge benefit from how we had done medicine. But our huge successes, the things that we really drove into the dustbin of history, were infectious diseases. But if you fast forward and you say, have we done the same thing to cancers and Alzheimer's disease and diabetes and these chronic diseases? Of course, we have not. And so what we argue in the book is that part of the reason was that we were so influenced, in some sense, rightly so, by the success we had in the 20th century, that we took this, as an infectious disease, you find the pathogen, you kill it. And we kind of turned that into find the target, drug it. And we have these huge enterprises aimed at these, trying to find a single drug target for really complex diseases. And then the nature by which the biomedical enterprise is set up, and I mean all the way back from research, starting from where I sit in that quite often, that you're a researcher, you're trying to study a disease, you're trying to get a paper out, you're trying to, move your career forward, and you have to do things in these chunks that are supported by an R01 or something like that. So what that means is that you've got to get a good separation between your case and control, your disease and your normal. You tend to go later in disease where you get a good p-value, get a good difference. You then identify it, and so we have millions of papers that focus on that model. And so what we argue in the Age of Scientific Wellness is that that kind of model is really suboptimal if you're trying to understand chronic disease and do something while you still have a chance to do it. So some big differences. So infectious disease is mostly about the pathogen. It's mostly about the infection. And there's some host issues, but that's the heart of it. And you kill that off and you're in better shape. Some exceptions, but that's the main thing. In chronic disease, it's a decay of your system. It may not come into play until much later in life, right? You're dying of Alzheimer's, unless you have really unfortunate genes that's not in your 20s, right? That's later. Cancer is mostly the same thing. Dear colleague of ours at ISB died from cancer, just very recently in his 50s. Continues to be a scourge. We all know people that that die from these things. So we've got that kind of issue. So your chronic disease is much more personalized to you, is one element. Your chronic disease is very dissimilar from other people's chronic disease. So that's one. It got to be a lot more personalized. Second is that there's usually a long period of time. And the earlier that you find these things, the earlier you intervene, the more likely you are to have success, and that is a familiar paradigm. But how do we actually orient ourselves much more that way? So what we came up with in terms of the idea for scientific wellness is, well, actually, let me back up. I want to give one more thing before I dive into that. So why don't we do more studies that are focused on prevention when we all know that it makes more sense to do earlier? And the reason for that is, as long as you're thinking through a disease lens, it is economically infeasible to do this for almost all scientists. Because if you think, all right, I'm going to go study Alzheimer's, but I want to understand what's happening 20 years in advance. And then you start asking the question, well, how many people do I need to recruit? How long do I need to watch them? What end do I, so what's the end that I need? What's the number? And you start putting together, and pretty soon you have a proposal that's like $500 million. And it will never be funded. You can never study it. You can't put it in. So no one does it. So everyone then studies, like we did for many years, working with great collaborators at the Mayo Clinic and other ones, but you study like post-mortem brain tissue, brain tissue that you get after people have died. You might learn something, but you're not going to learn what you actually want to know, which is, what could I have done to stop this 20 years in advance? So the main idea behind scientific wellness was, how do we set up a system so that we can, in an economically feasible way, generate the kind of data that's necessary to start to understand those processes that happen way before you get disease. And so what we came up with was this idea that if we provide a service to people where we try to help them optimize their health now, we do it with a real great density of data. And for people who are willing to let their data be used anonymously for research purposes, that if we can provide a service, make something that's beneficial to them now called scientific wellness, that will then generate that kind of data. And then as a byproduct of providing such a service over the course of some decades, we actually amass this deep set of information where we can study and understand what's happening way before diseases manifest, so that we can come up with ways to look across all the major human diseases so we can predict them and prevent them. That's a big challenge, obviously. That's a bold thing to aim for, but that was the goal. And where it doesn't make sense to do it on a one disease by one disease basis, if you say, okay, no, I'm not doing that. I'm actually agnostic to disease. I'm going to look at all diseases, but I'm going to try to just build a system that works for lots and lots of people, scale that up, ultimately to hundreds of, we've done it on thousands of people. We'd like to be doing it on hundreds of thousands, maybe ultimately millions. That would give us something that we've never had before, which is an actual deep insights into the data and the dynamic processes that happen in front of every single disease, which we have never been able to do before because there has not been a model for it to exist in the world that way. And so that was when we really became convinced that the whole enterprise needed to be shifted. And I'll give one example of that too. So I mentioned in systems biology, when you do these late stage case control designs, and I've done probably 100 papers on those, but you basically you end up, whether you use transcriptomics or metabolomics or proteomics, so just these global measures of all these molecules out of the body, right? You find hundreds, sometimes thousands of differences between your disease cohort and your normal. Now, when you do that, you then have to sort out at least three things. One, what's causal to this disease? Second, what are downstream consequences, right? Things that because of whatever cause or causes have cascaded that are out of line. Or third, what are compensatory mechanisms where the body's doing smart things to try to control it, right, to try to be good? So the fact that you see that something is different doesn't mean that it was good or bad. Those are all mixed together. Now, when we do this thing called scientific wellness and we're looking earlier and we start to use like genetics, for example, we look at people who are high genetic risk versus low genetic risk for whatever. What we find is that the signals in people on their asymptomatic are there. It's statistically significant, but they're sparse. There's like a handful of things that are different. And it appears, at least, in my going through it, they look to be very enriched for things that are causal. And so you start to have a movie of, oh, these small number of things happens, then these, and you go through it rather than just seeing a big mishmash at the end. And I think that's going to be really, really powerful for understanding the etiology of disease.
Yeah, you certainly, for me personally, in my career, it's been, different on a much smaller scale. But I mean, like I started my career and, studying isolated DRG cells, sensory nerve cells, because that's what my mentor at the time said. If you want to understand, something like irritable bowel syndrome, it's in these cells, And then I realized, and I was able to publish some important papers on ion channels, but I realized by seeing the patients that that's really not what the problem is, And fast forward. When microbiome science started to explode, it became pretty obvious to me that the microbiome science needs a different approach, not that pathogen-oriented single microorganism, which a lot of people are still pursuing, partly for IP purposes, so you can patent some molecule, but it's not. It's just a very different story, and also ran into this whole causality, correlation versus causality, because you can measure now everything difference between populations in every in every psychiatric disease, you see a group difference between, normal controls and a patient population, but very few of these are, just as you explained beautifully, are causal, because it's a snapshot. You don't know how the system got to the point where you're studying it. So that really opened my eyes. It's just grappling with the microbiome science findings, and I find it interesting that not all people have sort of embraced this paradigm shift. There's still a lot of people pursuing it in the old-fashioned way, and like you go to meetings, and particularly, I mean, this chatter on social media. There's this one organism that you need to take this one supplement to treat
Right.
the organism. That it's still very prevalent. People have not really. Um,
Well, people in general want simple answers, right? Well, simple answers are much more viral, right? If you say, I have the key to aging and it's one thing, and here's the one pill you should take, great. It doesn't interfere with the complexity of people's lives, right? If you say it's this complicated situation, then it makes it really hard for people to action. So one of the elements that I think is really important from that is that we do have to make it simple for people, because it has to be simple enough for people to action on, or it won't do anything. But we can take a lot of that complexity, and we can deal with that with algorithms, some of these new AI technologies and so forth. This coming in on board and into play, I think, is really important, because we have to deal with that complexity. I forget the quote. I'm going to not get it quite right, but I like it, where it's someone, they say, I don't care at all about simplicity on the near side of complexity, but simplicity arrived at the far end of complexity, I would give everything I have for that. I forget, some famous person said something like that, way, way better than I just did. But the point is that we want to take into account all that individual variability, what's actually going on in the person's body, what's going to make a difference, even up to things like digital twin simulations of expected outcomes from different interventions. But then you want to translate that and make it so that for the individual, they don't have to they don't have to go through like all that complexity. You make it transparent, they can go through it as much as they want. But at the end of the day, it's like, if you do these things, we make them as easy as possible. This is the desired effect, and you prove those things out. I think that is a big thing we've got to achieve.
Yeah, so there's sort of a key concept, or the way you summarize this in your book. So the P4 of this scientific approach to wellness, and that is predictive, preventive, personalized, participatory. That really seems to summarize the key challenges in this new paradigm.
Yes, and I think that's been a real organizing principle for a lot of what Lee and I have done over the last decade or so. So I'll just take them one by one. So predictive, obviously a big deal, because we want to be able to look at what's happening now and understand what's coming, right? Preventive, obviously, if we can predict it, you want to then step in and prevent it. Personalized, I alluded to that before, of how different individuals are. And one of the big scientific projects that I'm launching into right now is something that we call the N of 1 analyzer, which is the idea of, if I have a huge amount of information from one person, what can I say about it? How do I organize it? How do I deepen the insights based on that, which we could come to. And then the fourth P, which you mentioned, is participatory. And that's really key, because we want individuals to be at the center of optimizing their own health. I think that the ability for an individual to get educated now is the best. It's the best it's ever been. And within our healthcare system, and again, not throwing the baby out with the bathwater, right? You've got lots of people who can help, right? Your doctor, health coaches. But if you look at the healthcare system, the insurance companies, whatever, no one is totally aligned, from an economic perspective or a life perspective with your health like you are. And so owning that, participating in it, being an active in promoting your own health, your own wellness, and in understanding that to the degree you can is obviously key.
Yeah, I mean, one of the problems with this, this responsibility of the individual is right now people are confused. They're bombarded with information because there's not the unifying message coming from a modern healthcare system. So they're bombarded from influencers, best-selling books, New York Times best-selling books and it's almost like at this stage, what I see is the credibility of somebody who has 1 million followers is much higher on Instagram, or is much higher than a person like yourself, who's published over 1,000 papers, and whose knowledge and recommendations are based on hard science. And I think maybe hopefully it's just a transition period until the medical system or whoever is going to be that entity that promotes this new paradigm. It may not be these constantly growing, larger size medical centers that you see popping up everywhere. Like if you just look at the west side of Los Angeles, there's 3 major hospital systems competing, and one building after another goes up, and you often wonder, well, why do we need this massive expansion of the traditional medical system? So anyway,
Yeah,
this subjective component and how the individual who is concerned about their health and wellness now more than ever, how does that person maneuver through this confusing array of messages?
Yeah, I think it's a really interesting point you bring up. And I want to take it on 2 ways. So first, I want to deal with what you said that I think is really interesting, right? That person that has 1 million Instagram followers, right, has a lot more leverage in the world than somebody who's published hundreds of scientific papers that's definitely true. And I think, just in thinking about that as you were talking, that's very unlikely to change, right? Because the skill set of a person, or whatever it is, for getting those 1 million, followers on Instagram is quite different from the skill set of somebody for, doing, detailed science day to day. And so I don't necessarily think that it has to be the same person, right? It's not like, it's interesting, like in some cases it might be, but you've got to have a kind of a special skill set to do that. But I do think it's really important that we try to get these communities or different groups to talk to each other, understand each other. I think most people, that are out there as influencers, if they really, care about the truth, and I think, it varies, of course, but, a lot of them, I think, are just trying to understand what there is. It is an onus on us as scientists to make what we do as accessible as possible, to try to get out like what we know and what we don't know. There is a tendency for, like I said, simple answers, those kind of things do propagate more. There's system dynamics to this, but there's a really interesting systems problem to be had in terms of how do you actually make it so that things that are true can amplify competitively. So to get to the second part of your question, which is maybe, the most important part, which is, how do people navigate? And so that's also a complex question. I think finding trusted sources. So it's one of those things that, so what's the credentials or track record of a person that you're listening to in terms of, advice? Is there a reason to believe? If the claims are, some of it is also just understanding your own cognitive biases, which is, I think, really, really important to go through. So for one is, if you really want to believe something is true, that's a danger that, that you're much more inclined to believe that it's true than the evidence would suggest. So that's one. That's a particularly strong element, I think, when we start talking about things like longevity or individuals that that we can really make a big difference because it's something that we all want, and want to believe so much. So I think, so vetting is important. So trusted sources is a big one. That is, that's certainly one of my goals, with what we're trying to do with Thorne and so forth, is trying to say, can we help people, have a place where they can, trust in at least the products, the testing, the things that are going out are being done in a deep scientific way, such that you can believe that. And so I think you can try to find pockets, find, companies that have the kind of leadership that you believe in, institutions that have the kind of, that you believe in, people that have the level of depth and scientific integrity and so forth, that you can, and those things can go together. I think, Andrew Huberman was a good example, I think, of going through, lots of, trying to make science accessible to people. And and some of those episodes that he does are very long form, and some of them, surprisingly to me, are pretty detailed. Like some of them are kind of wonky almost, like well, that's not the right word, but they're, you might get into like the details of neurochemistry in a pretty deep way, right? And you think, no one will listen to that. And it turns out, no, freaking everyone listens to that. It's huge, right? And so I do think that there's a space for trying to do that. So anyway, that's a little bit getting too long and rambling, but it is a complex space, but to try to find those voices. And then the only other thing I'll say is that I am very excited about some of the possibilities with the large language models and the LLMs and so forth that we've got now, because especially early models, right, there are issues with hallucinations. There are issues with, can we get rid of those? But especially with some of the more modern techniques, what are called agents, right, where you now separate out not just an LLM that has to spit out an answer, starting with the first word and just in a straight line to the end, right? But now you can have a different agent that's an editor. You can have a different agent that then vets the scientific content of what comes. You can start to create like really high quality output. And I'm very excited about what that does for the average person, because you can, you hear a claim from an influencer, you can actually put that into, let's say, a really scientifically rigorous version of an agent, based, large language model, built on one of these, whether it's ChatGPT or Claude or Gemini or whatever, but you can build something like that. And I think that gives people an ability to go back and forth, ask follow-up questions, and get information, even straight from the scientific literature, but in language that they can actually understand. Mm-hmm. So, sorry, I'm thinking a lot here, but that actually brings me back to that earlier point, which is, that the influencer is maybe much better at communication than like the hardcore scientist. But hardcore science, maybe for the first time in history, can actually be made totally accessible to anybody of any, like capability, of any background, because of the nature of being able to have it described to them automatically basically at their whim with these kind of technologies. I think that's going to help a lot.
Yeah, no, I think that's a really good point. I mentioned that earlier that, I'm sort of been impressed by the bold and optimistic predictions that you and Leroy made in your book. So one is so a quote from the book: "We're on the cusp of a time when we will have the capacity to begin to eliminate most chronic diseases of our time, including cancer, neurodegenerative diseases, and metabolic diseases." So this statement comes at a time where you look back, like the war on cancer, more or less didn't really get very far. I mean, it did make progress, but Alzheimer's disease looks pretty grim in terms of major progress. Parkinson's disease, So despite these setbacks or lack of progress over the last 20, 30 years, despite a lot of research, you make this prediction that within 20 years now, we may actually have solutions and treatments for these, for these major chronic diseases of our current world.
Yeah. I do think the quote said that we will begin to. So we are talking about a shift. We're not talking about, the end of disease. There's probably a little bit of a happy medium between my view and Lee's view in terms of exactly how fast we think that might happen. But the reason that we did ground it that way, partly is I do believe that if we adopt more of the principles of what we're calling scientific wellness, and we have a reorientation of how we go about dealing with chronic disease, that in fact we do have the opportunity to greatly accelerate on these avenues, because our progress has been very slow. But I would argue in part that's because we've had the wrong lenses on, we've had the wrong paradigm, and that we've started, especially over the last 10, 15 years or so, to have tools by which we can make much deeper measurements. I mean, the genome was only sequenced, what, the first draft of this sequence was 23 years ago or something like that, so it's not, it's not actually been a super long time, but we can now make lots of measurements pretty cost effectively. AI is just sort of coming into its own in different ways. Those capabilities are getting much better. But one example that you bring up, I think, is really an interesting one, which is Alzheimer's. So Alzheimer's in particular is one of the cases where I'll argue that we mistook cause and consequence, as I was alluding to before. So working with a guy named Tom Patterson, startup company Embody Bio, with us at Thorne, we spent the last 3 years building out detailed digital twin models for brain health, right? So how does the brain stay alive? And then we layered on all this kind of information about Alzheimer's disease. And one of the things that really struck me as remarkable over the last few years was how much of the literature we could explain with these simulations that would track a person's trajectory over the course of life. And in building this, it actually changed my view of Alzheimer's disease pretty dramatically. So one of the things that comes out of this is that you can explain a huge fraction of, that we get into this, I think, in chapter 8 in the book, but the early version of this. But we can explain a large fraction of the data that's out there on different risks, known risk factors for disease, different genetics, the age at which these people get disease, and so forth. So when we simulate 10 million digital twins in this physiological model, you can explain that based on a pretty deeply metabolic view of the disease, which is that your brain, one of the big factors that is common knowledge about the brain is that it consumes about 20% of your body's energy, and it's 2% of biomass, right? So it's a huge energy hog. So you've got to satisfy that. So when we write detailed equations to model that in the brain, one of the things that happens as you get older is your oxygenation goes down. As your oxygenation gets less and less, and that happens in different regions of the brain at different rates, what you find is that the regions that go into those lower oxygen, your neurons can no longer maintain positive energy balance and they die. In fact, there's pictures of this. You can just watch it. UCLA did a beautiful study on this with PET imaging, and they die. When that happens, you start losing all this synapse firing. It turns out that under low oxygen conditions, just when you calculate the dynamics, you want to keep cholesterol levels in astrocytes, these supporting cells around neurons, you want to keep it low. Well, the other big factor that people know about Alzheimer's is that there's a gene, ApoE. ApoE4 gives you high risk for Alzheimer's. ApoE2 is protective. Well, ApoE4 has a role in the transport of cholesterol out of astrocytes, but it's really slow. So the concentration stays high and the energy generation in neurons is inefficient. Well, for ApoE2 does it fast. So that energy generation is efficient. If all you do is simulate that effect quantitatively against the backdrop of 10 million digital twins, what you find is that you predict almost just really closely the age of onset of Alzheimer's on average across all of the different genotypes. And anyway, we've done that for many, many things now. So one of the big paradigm shifts that happens is that as you go through and you're just piecing this all together, as your neurons die, you start losing synapse firing. Once synapse firing goes down below a certain level, a certain threshold, you can no longer do Hebbian learning, what fires together, wires together, right? How the brain learns. So the brain has to secrete a molecule to recruit additional synapses to keep cognition going. What is that molecule? Amyloid beta.
Mm-hmm.
Amyloid, which has been the target of 450 largely failed drug trials, where we've spent, there's different estimates floating out there, anywhere between 300 billion to maybe $1 trillion over the decades on attacking as the cause of Alzheimer's disease, something that is maybe better understood as a compensatory mechanism of trying to save your cognition as your synapses are dying. Now, does it create these plaques? Is that kind of a byproduct? Yes, it is. But if you clear out plaques from the brain, you know what the brain immediately does? Starts secreting amyloid again. And they don't get better, right? They don't get better. There's a little bit of benefit to one drug, but we get into the reasons for that. But anyway, writ large then, just to come back to the main point, is it's possible that we've made no progress to speak on Alzheimer's because wrong paradigm, we misunderstood cause for consequence. We had no long-term analysis like what we just talked about in Scientific Wellness, where we could watch the movie as it was going along, right? We haven't had too much of that. We're getting a little better with that with biobanks and so forth. But so that's why we have this sort of optimism. Like, we are very aware of the challenges that we've had up to now, right? And the cancer chapter gets into this, largely, a lot of failures in the war on cancer and so forth. But we wanted to have an optimistic bend because we do believe, and I really believe that if we shift the paradigm, if we shift it into a different model, that there is reason to hope. And and this landscape has changed a little lately too, I think, with I'm trying to figure out exactly how this fits in exactly, but something like the GLP-1 drugs are pretty interesting because they're aimed, I would argue that you can argue this either way, they're kind of aimed at prevention, right? They're not prevention in the sense that they are dealing with obesity, which already exists, but they are kind of aimed at prevention in the sense that obesity is a risk factor for kind of tons of different things. And they're also aimed at helping people to change behavior. And, and that I think kind of fits in a sort of interesting way. Those didn't exist when we, at least in their current form as, when we wrote the book. But I think there's probably going to be an unlocking or a class of, how do we kind of optimize earlier in these processes? Well, and statins kind of fall into that range a little bit too, but I think those, are going to have a place where we, and the economics around those are insane at the moment. So there's no doubt the drug companies are going to be pivoting, towards those areas. And that's why I think it's not only about, trying to, get everyone to just, behave as well as possible, and just have like the optimal, health and nutrition, kind of the ways that we think about it. That's part of what we want to do. But I think we've got to have solutions or interventions that really work on these problems, such that just the whole way that we're delivering medicines and solutions and approaches is just much, much earlier. And we're trying to adapt and do things before you get terribly sick. Like, that's really more the point.
Yeah, just to comment on these GLP-1 agonists and GIP agonists.
Mm-hmm.
So I've sort of gone back and forth on this as well, because you could say, and I got a lot of flack when we wrote a blog in our newsletter on this, saying that this is, this could really revolutionize, our dealing with this chronic disease epidemic. So a lot of people said, well, people should change their lifestyles and not, support the pharmaceutical industry. They just came up with a new way of making us dependent, which you could say it's true. We go from a state of being addicted to food for a lot of people to being addicted to these medications like the statins, and which you have to take lifelong. You can't get off them anymore. But on the other hand, it seems, sort of the evolving data that are coming out, not definitively yet, but that all these entities of the the chronic disease epidemic might be affected in a beneficial way, not just obesity, not just diabetes, but all the other ones as well that are downstream from it. And if that's the case, then obviously, I mean, together with, that the pharmaceutical industry will have to reduce the price of these drugs. But this could be a phenomenal solution to the problem, together with lifestyle changes.
Yeah, and multiple things can be true at once, right? Of course. Is there a financial incentive for the pharma companies? Yes. Could you have to be on it, forever? Maybe, right? There are ways we'll talk about in a bit. There's ways you could think about getting people off of them. But the flip side of those individuals that are like, okay, people should just change their lifestyle. Like, yes and no. I mean, at one level, of course, but if you look statistically, right, and like the New England Journal of Medicine papers, or when you do case control designs, like the number of people that just by, kind of just changing their lifestyle, that lose a significant amount of weight and keep it off for a long period of time, it's like 2%, right? I mean, it's very low. Success rate is very low. I mean, if you look at the New England Journal of Medicine paper, right, the people that are doing a lifestyle, like they lose some, but the average is like almost nothing. And the people on the drug, you're talking 5% success versus 95% success. So the rate of difference is pretty massive. So I think that's I think that kind of speaks for itself in terms of efficacy. There are also all the other issues. And there's reason to be skeptical of any drug that that you need to be on for long periods of time. It brings us back to the microbiome in some ways, right? There are of course GLP-1 agonists that are made by the microbiome. So you could imagine optimizing your microbiome in such a way. Now the effect size there is of course way smaller than these engineered GLP-1s that have these long half-lives. So I don't want to be glib about that there's that those are equivalent because they're not. But that said, at some point you're not trying to lose weight anymore. You're just trying not to have, you're just trying to be able to maintain an equilibrium. And we can, via microbiome modifications, supplements, good diet, good practices, exercise, all those things, you can, create a situation where I think you can get yourself to, to a maintenance phase. But that kind of Herculean task for somebody that has to lose 60, 70, 100, 150 pounds by lifestyle.
It's not possible.
The Biggest Loser, television show was a good example of that. Like with a coach on TV for 9 months, did they do amazing things? Absolutely amazing. But there was that heartbreaking article that came out that said, I forget the exact number, but a huge fraction of them were obese again, a few years later, even after that life-changing event. And so I don't want to put a social stigma on people that, that find this to be the solution for them. I think it's been a pretty remarkable. And I am bullish on it from the notion that that if we could do similar things, for example, around fundamental mechanisms of aging, right? We're kind of attacking obesity here. If we could do things like that around aging, right? We try to hit some of those kind of things with supplements now, but we could turn some of these, maybe they could be drugs. They have to be different classes, right? They've got to be the safety profile is different, like I said before. Chemotherapy is like on the extreme end of, if you're not dying, you're never doing that because it's terrible for you. Versus something like a GLP-1, rapamycin might fall in that category. Metformin's being tested to fall in that category. There might be a number of things that can be that can help us avert damage. And if we can show that and it's effective and you can track, that's important. Oh, one thing I'll say along those lines on statins is an interesting example. So statins, of course, will lower LDL cholesterol, right? And you can use that to lower your risk of cardiovascular disease. But there's a big side effect for statins, which is that there's a 9% increase in the rate of diabetes. for statin users. So one of the things that we did is we actually did a study using all this data from this previous company that I'd co-founded called Aravale, which came out of the Pioneer 100, which we've alluded to this. I guess I haven't actually said this too much, but we took 5,000 people through these kind of programs. We've published a ton of papers on this. This is one of them. And so one of the papers that we did, this was with Sean Gibbons, a colleague at ISB, was to look at individuals on statins and their microbiomes. And it turns out if you take the microbiomes, you can break them into 4 different categories of microbiome roughly. And it turned out that for one of those categories, people on statins got double the lowering of LDL cholesterol that the others did. So the microbiome has this big effect on the efficacy of statins. Now, we also looked, because we had all the diabetes markers in these people as well, at who on the statins had elevated diabetes, either diabetes or pre-diabetes markers. And it turned out the microbiome was, again, really predictive of that. For 2 of the groups, you had very significant movement towards diabetes. And for 2 of them, there was no indication at all that there was any movement towards diabetes of those. So again, and these predictions from the microbiome are much stronger than any known genetic effect. So there's so many of these kind of things that we're just at the, the early stages of learning and understanding. So there's just so much that you can get into in personalization and optimizing a microbiome and understanding what's going on. So as we start opening this up, I think we're going to find that there's just so many things we can do from an intervention standpoint that are so much different than what we could think about before.
Yeah, we've almost come to the end of this conversation, and I would love to. I mean, there's still so many topics we didn't address. Maybe at some future point we could have a follow-up podcast on some of these. But I was going to bring up one last thing. So a major challenge of implementing this transition is the successful business model of the current system. So what I like to call the medical, pharmaceutical, industrial complex. Obviously very powerful, generating billions of revenue for more for the corporate players rather than the individuals that are contributing to this. And I mentioned this earlier, this rapid growth and expansion of medical centers. How do you think that transition that you are predicting is going to happen? I mean, you almost need a buy-in of these big players right now, because I mean, just like in terms of the diet, unless you get a buy-in of the of big agro business and the food suppliers, you won't be able to solve this problem of an unhealthy diet. How do you think that will happen? Will the evidence be so strong that this will have to come from the political level, that people say we're no longer going to pay for? So reimbursement, for example, will reimbursement change that landscape?
Yeah, I think you've really come to the heart of the issue, because that is one of the challenges is, of course, the massive economic success of the current model, right, which takes almost 1/5 of the economy now. So there are a number of ways that needs to be addressed. So one is feeding in and getting insurance coverage, I think, is important. And that is one of the ways that we've just got to create, the evidence base around this that's got enough data to get, insurance executives to buy into that. That's a particularly hard challenge, because in some cases, there probably is plenty of data that shows that it's good from the standpoint of the individual. But insurance companies are optimized. Sometimes they'll tell you they only care if you can save them money this year. The furthest out I've ever heard is that they'll care about 3 years. So they really want to see that it helps them in the short term. Now, I was talking to a very high-level insurance executive recently, who really likes a lot of the work that we've done. And one of the things that he pointed out that I think is encouraging is he said, especially when we're not talking about drug interventions, right? If we're talking about the rest, he said, I don't actually need any federal agency or the FDA or any, there's like to do approvals. All that is necessary is that I believe that it's a positive ROI. Because he's like, I can ensure everything you're talking about here for prevention I can do if you can convince me that I'll save money in a very short period of time. And so there are movements like that. There's some really interesting companies that are coming online now around value-based care that I think are very exciting in terms of trying to solve the kind of the economic model of this. Trying to remember exactly how much of this was in private conversation versus public, so I won't get into too many of the details on that. But those are coming around now, and I've been very compelled by some of the business models that are being put together that way. I think that scientific wellness and these approaches can compete very well. I think one of the biggest issues is going to be how the government treats these things. Because, and I think this is where the participatory really matters, that we as individuals have to be advocates, including with the government, to not block solutions that are very cost effective to us. Because the status quo, there's a huge amount of money that flows through there. And there are a lot of elements of that want to use the government as a way to block access from people from getting, information at low cost, at being able to get, solutions that are more readily available to them, again, at lower cost. There's so much inefficiency in our bloated healthcare system that it's pretty staggering. In fact, I went to a really interesting lecture. It was at Mount Sinai some years ago, and I've never forgotten it because he was going through an analysis of various industries and how they had improved in efficiency and delivery and lowered in cost, right? So like the tech industry is a great example of this, right? You just lower, right? Our compute power, per dollar is just, you get way more per, we all know this, right? Your computer gets faster, it doubles every year and a half in terms of like processing power, et cetera, et cetera. Then there was another industry, not a recent industry, farming, right? And it showed how farming was getting better. But there was one massive outlier that had become more inefficient over time since the 1980s, year over year, where everything costs more, less efficient, less than you can, of course, guess where I'm going. What was that? Healthcare. And so it has been, and so it is kind of an albatross. And so one of the things that is massively necessary is to get buy-in at the highest levels. And it's going to be incredibly hard because of all the money that you mentioned. So we need a lot of grassroots, push for this. This was partly, why we wrote the book and why, in our, very small way of throwing our pebble at the giant, the enormous giant stone. But it's is that if there's space to innovate and build these things out, I think that the advantages of this kind of approach are pretty clear to individuals. And to the extent that that is allowed to be, played out in, in a free way in the marketplace, I think it has a very good chance of succeeding.
Yeah, I think this is a good point to finish our conversation. It was fascinating. I have to say, most listeners will have the same impression. And as I said, I mean, there may, there's almost certainly enough additional material that we didn't touch upon that I would love to come back in some time. And
anytime, man, just let me know.
So
Awesome.
Thanks, Nathan. Yeah, good luck with the predictions. I think that many of your predictions will come true. I'll certainly be on the side of propagating some of the same messages on my small scale as well. So thanks very much.
Yeah, thanks a lot, everyone. Great to be with you.
Take care. Bye-bye.